Hey guys, welcome to another video. So today, another question from the Nice Question series. Today's question comes from the Extension 1 syllabus from the Baulkham Hills 2024 trial paper. So a nice question on the topic of differential equations, more specifically the applications of differential equations, which can be quite challenging, right? There's a lot of calculus integration involved. So a nice question. So before I dive in, as always, if you haven't already done so, please subscribe to the channel, like the video, and tell your friends. Guys, let's get started. So, Baulkham Hills, I believe it's the last question or second last question in the paper. So generally reserved for quite a hard question. I mean, Baulkham Hills traditionally has quite challenging papers. So, this question's quite nice. So let's dive right in. So first question. Using substitution method, it's an integration question. Okay, that's not too bad, I think, I hope. And then a team of scientists is studying species of growing trees. Rate of change of the height is given by this. Okay, that's the rate of change, where h is the height of trees and t is time. Easy. According to the model, what is the range of height in heights of trees? Yeah, so I'm assuming the fact that it's growing trees, right? This guy's always positive, so I think we can get something done there. And the last question there, one of these trees is 1 meter in length, not 1 meter high when it's first planted, right? So that gives you information. I'm assuming for the integration, we need to find the constants with that. And according to the model, calculate the time. So they want time here, right? Yeah, when it reaches 16. Okay. So the flow of the question is, let's integrate, and then for part two, it feels like we're just going to find the domain of or the range of heights, and then part three, your classic application question where we integrate that differential equation to make, I think, t the subject, or find also h subject, and then find time. Okay, cool. Let's do part one. Start writing. All right, so part one. Now they want me to basically integrate, right, dh. I'll split it, Let me split it. So 1 on 9 minus root h dh when they're using the substitution u equals to 9 minus root h. Okay. So as always, differentiate the substitution du dh. Now, 9 goes away. That's just, if you know, I mean, maybe I'll skip it, right? Differentiating square roots is 1 on 2, right? 1 on 2 square root, right? 2 root h. As such, so now, okay, so I'm just going to make dh the subject. dh would equal to negative 2 root h du. Yeah, I think that's right. And then, okay, so what I'm going to do now is sub this, oh, sorry, replace u into here, and then replace this into here. Yeah, and now I know what you're thinking. I know what you're thinking, right? That when I sub it in, oh, sorry, that's you now. I still got h's in there, right? I still have h's in there. So last part of the substitute. So go back up to your original here and make root h a subject. Oh, maybe make negative root h a subject, right? So it just becomes u minus 9. And I'm just going to replace that with that and that. Right? So it becomes like, I'll bring the 2 out. And u minus 9 on u du. 0, 2 outside. Or maybe here. Looks like it rings multiplied by 2. And then to integrate that, split. All right. By the way, substitution method, the whole point is to replace all the x's we use. I've done that now. So now it's just integrating this guy here, split that fraction 1 minus 9 on u, which is really easy to integrate now. So 2 outside of u minus 9 ln absolute value u plus c. And then all I have to do now is plug. So I'm just going to zoom out because I'm going to get this arrow, plug that back into the value of u and u, and then expand. So let me see. The negative there. Have I done something wrong? There's a negative in front of my u there. Have I done something wrong? Is there limits? No, there's no limits. How come I'm getting a minus? The question says there's a minus in front of the u. No. Okay, so when I sub this, it's a bit, okay, yeah, okay, good. No, all good. So I sub it in, and you get 2, 9 minus root h minus 9 ln 9 minus root h. And all the question has done is that, yep, they've expanded this, right? They've rainbowed this, right? And they've said minus 18 ln 9 minus root h, and then minus 2 root h. Yep. Okay. And then what they've said is basically 2 times 9 is 18, but that's a constant. And then I added with the constant, so it just becomes constant, right? So they didn't actually have that 18 anyway, which is fine. So therefore, that's what I want. Yep. So the 18 sort of disappears because it gets grouped together with the c, right? It's an unknown constant. Boom, done. How's that? Yep, that's the integral part. Now, part 2. So it looks like part 2 basically says, here's my differential equation for the growing trees, right? The rate of change of the trees. Find the range of tree heights in the tree. So first thing I should note, right, when doing part 2, let me do part 2 here and I'll move it. Yep, part 2 here, so I can see the formula. Is that dH dt is always positive, right? Because it's growing, right? It's always increasing, right? Growing trees. All right. So therefore, I'm going to set that differential equation. So t 0.5, so 9 minus root h over 18 is always greater than 0. Now, t is time, right? So this guy's always positive. Yeah, so this guy's always positive. Okay? T is greater than 0. Oh, greater than equal to 0. Yep, that's gone. And 18's gone. So I can actually delete that, right? Because I'm going to move it over the inequality with the 0, and it doesn't change the inequality because they're both positive. So that leaves me with 9 minus root h is greater than 0. So then root h is less than 9. Square both sides. Now h is positive, so I can just square both sides. Oh, sorry. Yeah, h, the square root, h is a positive number, right? So less than 81. Okay. So that's my upper bound, right? H is always less than 81. And also because h is within the square root, yeah, and h is always greater than 0, right? Can't be negative, right? Because it's inside the square root. So therefore, my height is bound between greater than or equal 0 and 81. Yeah. Is that okay? That's my answer. So my range of trees has to be between 0 and 81. So let me just move that. Maybe. Perfect. Is that okay so far? So now part 3. So part 3 says, basically, I'm going to use my differential equation skills to take that differential equation and find the value of h, right? So let's go there. So I'm going to, okay, come over here, part 3. So dH on dt equals to t 0.5, 9 minus root h over 18. So I'm going to bring dH, I'm going to bring this guy over, right? And then I'm going to leave dt with that function of t and the 18 there, right? So bring that over, you get 1 on 9 minus root h dH equals to t 0.5 5. And I'll bring the 1 on 18 outside, right? With no dt, because I'm going to integrate both sides. Yeah, to bring the 1 on 18 outside. Now, guys, for this expression, that is already done, right? I've already got that from part A. Oh, so part 1. Yep. So I'm gonna basically go that equals to negative 18 ln 9 minus root h minus 2 root h. I think, was it? Man, good memory. Yep. And I know it's plus c, but both sides have an unknown constant, so I'll just do plus c once on the right-hand side. So this one here, 1 on 18. Now that's just add 1 to the power. So 3 on 2 over new power plus c. All right, let's just clean that up slightly. So I sort of got, so they have like negative 18 ln 9 minus root h minus 2 root h equals to what's that, guys? That becomes 9. Is it 9? So 27. That sound familiar? Yeah, 27. The t 3 on 2, 27 plus c. Okay, sweet. Now, there's no point in me making h the subject or making t the subject before I find c. So I'm just going to sub in that point. So when t, what is it again? So over here, initially, one of these trees is 1 meter high. Okay, cool. So this is basically saying when t equals 0, h equals 1. Yeah, okay. Oops. Okay, so when t equals 0, h equals to 1. So then negative 18 ln 9 minus 1, then square root of 1, then 2 times 1 equals to c, right? Because that's 0. So then c equals to negative 18 ln 8 minus 2. All right, so then once you get that, we plug this back into the constant that's missing there. And then the aim is to sub in h equals 16. So what I'm going to do, once I plug it in, I'll try to somewhat make t as clean as I can. So sub that in and you get negative 18 ln 9 minus root h minus 2 root h. There's no point in making h the subject record because I'm subbing in a value of h. So t 3 on 2 on 27 minus 18 ln 8 minus 2. Yep. So right now, when h equals to 16, I think it is, right? H equals, okay, yep, good. H equals 16, I need to find time, right? Now let's see how much space I got. Okay, a little bit. So it's gonna move this up. Yep. Okay. So then now I'll sub it in and I'll move everything over as well. So maybe I'll try to make t 3 on 2 and 27 the subject while subbing this stuff in. So it'll be negative 18 ln 9 minus 16. So that's 4 minus 2 times 4. And then plus 18 ln 8 plus 2. Right? So bring those two constants over. So ultimately, I'll punch this in the calculator, times it by 27. So t 3 on 2 was a 27. Outside of now, it'll be 18 ln. So if that's ln 5. So 8 on 5, is it? Yeah, ln 8 on 5. And then minus 8, so minus 6. Right, and then I'll basically bring that over. Right, 18 ln 8 on 5 minus 6 power 2 and 3. Nope. So punch out in the calculator. Yeah, that's your answer. So I think you get maybe, I don't know, 1 dp, 16.4 years, right? Yeah. Guys, how's that question? I thought it was quite nice. Had a good integration substitution to begin with. And then the context of the question, the differential equation was quite nice because it's got both a function of t and a function of h. The integral for the blue part we got from part one. And basically, it's just a messy question thereafter with messy numbers, but it's not too bad, right? They gave you numbers to sub that in, and you get 16.4 years. Guys, if that was good, please like the video, subscribe to the channel, and tell your friends. Thank you very much. I'll see you next one. Thank you.